All right, up next is our two variable data. So two variable data is when we're talking about a relationship between two quantities, x's and y's. Okay, that's when we went from um, something simple to something like, oh my gosh, there's letters in math now. Do you remember that transition? That's what took place, right? So there are 5 ways that relations can be represented. So when we're looking at the 5 ways, we have ordered pairs, we have a graph, we have mapping, we have a table, and we have a function, right? Um, those are, or an equation, I'm sorry, an equation. So these are our 5 ways to represent relations, okay? Remember, we're going to talk about a little bit more, but not every relation is a function, correct? Not every relation is a function. There are some things at play, okay? When we are describing relations, we describe them in terms of domain and range, right? What's the domain of the relationship? What is the range of the relationship? Everyone remembers that? Okay, so let's talk about domain and range. If you've had me before, you've heard me say Dixie and Royd. Okay, hopefully not. All right, Dixie and Royd. Remember, to me, Dixie and Royd are two hound dogs. Let's try that again. All right, so Dixie and Royd are two hound dogs sitting on a porch, but what do they represent? Well, Dixie represents all things domain, okay? The domain of a relation is a set of input values, your x values, and the Dixie stands for all the words that would represent domain. So we have our input, our x value, and your independent quantity. Each one of these words are used at different times. Does that make sense? So your input is more so used when you're working with a function and you're plugging something in and getting something out, right? Your x value is typically when you are graphing, when you have an x and y coordinate. Make sense? And then your independent quantity is when you are describing actually what it is. Instead of just saying X, my independent quantity is time, right? Is when you're actually describing it. Sometimes it's called independent variable, but it's the same thing. Okay. Your range is your relation in the set of a relation. I'm sorry, the range of a relation is a set of your output values, your Y values. So for range, our output corresponds to the input. If I input something, I'm going to get an output. For our ordered pairs, there for every X value, there's a Y value, right? There's a Y value. And then your dependent quantity is what does it represent? So like if I'm comparing I don't know, ages to shoe sizes, right? The ages is my independent quantity and the shoe size is my dependent quantity. Okay. That's when you are giving them a name. You're not just saying domain and range. You're saying, what does your domain and range represent? So which one you use depends. Okay. Let's keep her going. So we're going to start here. Pretty simple. We're going to find the domain and range of a relation. So here we have a physics class measured the time, y, that it takes for an object to fall, x, as shown in the table. The object was dropped twice from each height, okay? So it was dropped twice from each height. The first time, from 20 feet, it took 1.2 seconds. From another time, at 20 feet, it took 1.1 seconds. At 40, it took 1.5 seconds. At 40, again, it took 1.6 seconds, okay? So what we're going to do is write the domain. When we write I'm sorry, we're going to express the data as a relation. When we say we're expressing it as a relation, that means we're going to write it as either a mapping or as an ordered pair. We're going to identify the x's and y's and write them accordingly. So we're going to have x, comma, y. Okay, so that is our set that we've defined. Okay, I went through and like typed it out because me writing braces, I'm terrible at writing braces. They just get a little weird. Don't worry, you'll get to see some of my squiggles later. But for the sake of now, here they are. So we come from understanding that taking a relation and representing it in one of the 5 ways. Easy enough? Okay, we should be able to toggle between the two. The domain. So the domain and range of this, we're going to write it as a domain and range of a discrete data set. What discrete means is discrete means that there's particular points. It's not continuous. It's not going forever to the left or forever to the right or forever in both directions. It's a specific situation. So this is a specific set of data. So when we write our domain and range, we're going to list out all the values. Okay. So for example, my domain here would be 20 and 40 because those are the two values in my x's, right? My two x values. All right. Yes. Yes. Since you don't want to lead it. Yes. Hold on. Okay. Okay. All right. And then our range would be our values. Notice that when you're listing out the domain and range, they have to be in some type of sequential order, okay? Whether it's least to greatest or greatest to least, it doesn't matter, but they need to be in sequential order. Make sense? Okay. Also notice that we repeat the 20 and the 40. You only need to write each value one time, even if it repeats in your data set. Okay. Do we vaguely remember our intro to two variables in Algebra 1 and seeing us write this as discrete data set, discrete domain and range? Y'all remember doing that? They're currently doing it right now in Algebra 1, so I know it's taught. It's part of what they're learning right now as we talk right now. Well, either way, all Algebra 1 should be learning it. You spend the same year going over the same stuff, so you better know something. All right. So questions about writing the set as an ordered pair and identifying the discrete domain and range. Easy enough. All right. Next, we're going to talk about our Cartesian coordinate plane. Okay. Cartesian coordinate plane just simply means that we have x's and y's, correct? So our x and y plane. With our x and y plane, we're going to label the important pieces of it. Your horizontal axis is called the x-axis. Your vertical axis is called your y-axis. You have positive x's to the right, and you have negative x's to the left. Positive y's to the top, and negative y's to the bottom, okay? Your axis of symmetry, your axis intersects at the origin, so your intersection is right here and that's going to be at 0, 0. That's the point where it's nor positive nor negative. We're neutral. You have 4 quadrants. Your 4 quadrants are numbered in numerical order counterclockwise. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? The quadrants are important and easily identified based on the signs of your x's and y's. So you know that a value belongs, well, yeah, we'll call it value. A value belongs in a quadrant based on its sign. So for example, in quadrant 1, if my x's and y's are both positive, that's a quadrant 1 ordered pair. If my x is negative, but my y is positive, that's a quadrant 2 ordered pair. If I have double negatives, negative x's and negative y's, it's a quadrant 3 ordered pair. And if I have a positive x and a negative y, that means it belongs in quadrant 4, okay? What you see right now on the graph is called a scatter plot, okay? A scatter plot is a graph where you have distinct points plotted. Like there's no connection to them. It's just the information has now been plotted on the graph. A scatter plot is just a relation. A scatter plot is not automatically a function, okay? It's just a relation because you're comparing x's and y's, or you've collected data between an x and a y. All right. We all knew this, right? Yes. A 0, 0. Yeah, no. For some reason, when I try to like loop around things, sometimes it doesn't close it in this app. All right. Cartesian plane, aka the x and y coordinate plane. How we feel about it? All right. So graphing a relation, you should already know how to do this. You see I wrote it there? Okay. Complete the following for the relation. If I asked you to graph these points, could you graph these points? I would like to believe you could. So to make sure that we can, we're going to identify what quadrant they should fall in. Okay. All right. Starting off here, what quadrant should 510 be in? First quadrant, quadrant 1, 5, -5. 4, negative 10, 10, 2, 0, 15. Ooh, it's a trig. Is it in a quadrant? It's on your y-axis. That says axis. Remember, we're going to all support that says axis. Yep, it says axis. We see it. Okay. And then negative 15, negative 10. Quadrant 3. Okay. I'm going to trust that you all can do that. So what that looks like. So the domain of this set is negative 15, negative 10, 0, and 5. That's again because we have specific points. So we have a discrete domain, which means that I'm going to list out each value in numerical order. Make sense? Okay. If I ask for the range would be the same. The range of this data, again, we have specific points, and we're going to list it out. Notice I only wrote 10 how many times? 1 time. Okay. Just because it repeats does not mean I repeat when I write the range out. Okay. When you have a relation, you also still can identify your maximum and your minimum. You just specify which one you're looking for. Okay. So like with single variable, you automatically know it's just one of one, right? With your relation, you have to say, are you looking for the maximum max x or your max y or your min y or your min x? Okay. So for this case, just for practice really quick, we're going to do both. What is my maximum x value? Oh, wait. Maximum x. 5. 5. It is 5. Okay. Look at your domain. What is your highest? Okay. And then what is your maximum y value? Now it's 15. Okay. What is your minimum x value? Negative 15. Minimum x value. What is your minimum y value? Negative 10. Okay. That's it. That's all you're doing. Okay. The only difference again between the single variable and the 2 variable is that you just have to clarify whether you're looking at the domain or the range. Got it? All right. And then the next thing is to be able to plot the points. Again, we're not going to actually plot the points because at this point, I believe that you know how to graph. Okay. Were we correct about the quadrants they fell in? Oh my gosh. Good job, guys. You're genius. I knew it all along. All right. Questions about relations and 2 variable. Questions, comments, concerns?